let's jump into Spotscale's presentation. Katarina, are you there?
Yes.
Wonderful. Share your screen and take it away.
Thank you very much. There we go. Can you see it?
Perfect. You're good to go.
Super. Thank you. I'm Katarina from Spotscale. And thank you very much for having me here among these great presentations. And the case I choose to talk about today is how we help Core. How we help Core bring insights about buildings to their customers. They have developed a concept they call Core Smart Drone, which they offer to all their customers. And Core, as some of you may know, is a facility management company. So if you are a real estate owner, you can buy all the services you need to take care of your buildings and run your buildings through them. And at Spotscale, we are experts in 3D reconstruction from drone imagery and image analysis of the exterior of buildings, both regular images and also thermographic images. So I'll tell you a little bit about two of Core's smart drone projects today. And the first one is at Nya Karolinska, the Swedish hospital in Stockholm, which you can see on the image there. And the reason for using this technology here is that there are guarantees that are running out in the coming years. So it's time to find out if the buildings are working as they're supposed to, if the materials are of enough quality, etc., so that you can contact the contractor if the hospital is already falling apart. But so to assess this on the outside of the buildings, taking high resolution imagery of all the facades and roofs is a good start. And what we do on our cloud then is to process all those images into a high resolution 3D model where anyone can inspect this building from their web browser on the computer. So what you see here, I've changed my mind. I'm not going to show you the demo, but I'm happy to send anyone a link of a 3D model so you can spin around and zoom it yourself. I'm just going to show you some screen dumps now. So I don't have any problems with the technology. This is just one facade, as you can see, of the hospital. We did a pilot project to test it out. We did this in late December. That's where you can see it looks quite dull and boring, but what's interesting is what you can actually see in this 3D model. So the pilot project aimed to see if we could use this method. I mean, the alternative method they had in mind was having actually people climb all the facades, climb with ropes, take notes and take photos. So this just collecting the data here is what's much more efficient. And we wanted to see the resolution here in the images is about 2-3 millimeters per pixel, which makes the resolution of the 3D model around 5 millimeters. And it's enough to find anomalies and faults on the facade. Here we can see some. If we zoom in, you see some dirt here on the facade. We can measure it. And also since the 3D model is made up of all those images, we can always go back and look at the original images and also our measurements and our notes and everything is connected in 3D space, so we know where we are on the building. There are thousands of images just of this facade, so this is a nice way to organize them. So anyone can just zoom in, spin around, look at the images. And the plan ahead, we also wanted to test the data collection method. I mean, this hospital is in close proximity to Bromma Airport, and they have a helicopter pad on the roof as well. And also the integrity of people there, we wanted to make sure that we could do this in a safe way, and we have an automated process of taking all information. There are no people in the images or in the 3D model, no license plates, etc. It's automatically taken away. But Core wanted to make sure before we do a whole hospital area that this actually works properly. So the plan is to do the whole hospital and also do infrared on the roofs. This kind of facade is unfortunately not suitable. It's like bricks that have a layer of air in between the actual facade, and so it's not you can't really find. It's hard to detect heat leakages through this type of facade with infrared cameras. but the roofs are going to work. But leads to the next case, another smart drone project that Core has done together with us. Here the end customer has a secret facility, so I'm not going to show you that one. I'm going to show you a similar one, but you'll get the concept. It's the same technology and the same outputs. So the building here is photographed both with RGB, a regular camera, and as well as an infrared camera. And the reason is similar. There's a guarantee. They have done some work on the roofs to ensure that the energy bill is going down, and they want to make sure before next winter is coming and the energy bill is coming again. They want to make sure that the energy leakages are less than before the renovation. So infrared images are best collected at night, or you can do it at daytime as well if there's a heavy overcast. If you want to find energy leaks, you can find moisture as well in the roof if you have good timing and do it after rain. When the roof is drying up, you can actually find moisture as well, if that's what you're looking for. But in this case, they were just looking to see that the installation is properly done by the contractor. So here again, happy again to send you a model you can spin around for yourself and zoom in if you like. These are some screenshots. You can zoom in. You can also switch between the infrared and the RGB imagery. If you find something you think it looks suspicious, you can see maybe that's just a vent and it's supposed to be hot there. You can also switch, in this case as well, switch back to the original images and get the temperature in each pixel. Yes, so we are doing this. We have we work closely with FLIR, the camera maker. I was happy to see Anna Karn here, who was at FLIR before when we started this project some years back. But that's what I wanted to show you again. And as I said, I'm happy to send you 3D models if you want to spin them around for yourself. And just reach out if this is of interest to you or your customers.
Great. Thank you so much, Katarina. Brilliant.
Thank you very much.